Welcome to all the students. This is Rajiv Kumar Soni, and I will be taking your second lecture on simple lifting machines. Now, in the previous lecture, I told you some of the important things about the simple lifting machine. That was the basic definitions, the basic concepts, and the basic terms in simple lifting machine, and all were very important to be learned by you. Now, in the last topic, I told you how the working of the machine can be represented graphically. I just want to add one point in that. Now, in the last lecture, I told you that whenever the machine, I'm talking about graphical representation, in that I told that input and the output were equal. But that is just in case of an ideal machine. But in case of actual machine, the input is always more as compared to the output. Okay, because every machines have got some of the friction, and to overcome the friction, the input is always more as compared to the output. Now, again coming to the same topic, suppose this is the graphical representation of the working of the machine, where work is equal to force into distance. Now, suppose this is the amount of work which has to be done by a machine. This is known as the output. So this is the work, and in this work the force is 4 Newton and the distance is 4 meter. And if we multiply, that is the area of this figure tells us about the work done, which is the output. So output will be equal to 4 Newton into 4 meters, which is 16 Newton meter. Okay. Now, if we use the machine for doing this work, then definitely the machine gives us an opportunity or the option of reducing our effort. Suppose now we have reduced our effort by using a machine. Suppose the effort has been reduced to 2 Newton. This is 2 Newton. So whenever the effort reduces, the distance covered by the effort will increase. Now suppose this is the distance covered by the effort. Let it be 8 meters. So this will be our input. Okay. So this area represents the input and this area represents the output, and the input becomes 2 into 8. Again it is 16 Newton meter. But actually saying this is for only for an ideal machine, but in actual machines the input is always more as compared to the output, because every machine has got some friction and we have to even overcome the friction. So to overcome the friction, the input is always more. Now to increase our input, let us increase the distance moved by the effort. Suppose this is the distance, increase in the distance moved by the effort. Now let it be 9 meters. Okay, so this area, the whole area defines the input in case of an actual machine. Now the input becomes 2 into 9, which is 18 Newton meter. Okay, 18 Newton meter for actual machine and 16 Newton meter was for the ideal machine. Now the efficiency is equal to output upon input. Okay, so output is 16, and in case of ideal machine the input was also 16, so efficiency was 100%. But in case of actual machine, the input is now 18 Newton meter. So the efficiency become 16 divided by 18, which is 88%. This is the efficiency of an actual machine, and this is the efficiency of an ideal machine. So ideal machine is only the theoretical concept. all the machines we come across are actual machines in which the efficiency is not 100%, it is always less than 100%. So actual machine, in actual machine the efficiencies come to be about 88%. Even if the efficiency of a machine is less than 100%, then also we'll prefer to do our work with the machine, because machine gives us an opportunity to reduce our effort. Okay, now suppose you are driving a car and the tire got punctured. So to change the tire you have to lift a car. If you don't use a machine, you have to lift a car, you have to exert large amount of force, which is not possible for you. So you will have to use a machine. So with the help of machine, the effort which you apply will be reduced, but the distance traveled by the effort will increase. So our main aim is to reduce the effort, because this is our main problem. The distance traveled by the effort is not our problem. So definitely we'll make use of a machine even if the efficiency of the machine is less than 100%. Now the second topic, coming to the second topic, the next topic is the friction in a machine. Okay, now I think all of you must have heard the word friction. In general, if you want to explain the friction, then a friction, whenever any two objects are in contact with each other and one object tries to move on another object, then a resistive force will be developed due to the interlockings. This resistive force will resist the motion of one body on another body. This resistive force is known as the frictional force. That is the general definition of a friction. But in case of a simple lifting machine, there is a little different definition. Now in a machine, not taking lifting machine, in a lifting machine you have to lift an object, and to lift an object you have to apply effort. Let us take an example of this lever arrangement. Suppose this is the lever, this is the fulcrum. The fulcrum is the point about which the lever can rotate like this. Now suppose the weight is kept here and you want to lift the weight. So whenever you want to lift a weight, you have to apply an effort here. So by applying effort here, the weight will be lifted like this. Okay, like this. Effort applied here, weight will be lifted like this. Now suppose the weight which has to be lifted is 10 Newton. Now the effort applied to lift the weight of 10 Newton will always be more than 10 Newton, because you have to overcome the frictional losses also. Suppose here is a friction of 1 Newton. This is the friction in a machine. So you have to lift 10 Newton, and even you have to overcome this friction. So you have to apply a force or an effort of 11 Newton. 10 for lifting the weight and 1 for overcoming the frictional losses. Now our applied force or the effort will always be more as compared to the weight which is being lifted up by a machine. Now in this case, the output of a machine is always less as compared to the input. So that difference of input and output is due to the friction, and it can be the definition of the friction also. That is, the friction in case of simple lifting machine can be defined as the difference between the input and output of the machine. Okay, because the difference is due to friction. So the difference is the friction. Now friction in case of simple lifting machine can also be defined on the basis of the weight lifted and on the basis of effort applied. Now see, the weight lifted 10 Newton, the effort applied 11 Newton. So effort applied is 1 Newton more as compared to weight lifted, and the weight which is lifted is 1 Newton less as compared to the effort applied. So if you want to now define the friction on the basis of effort, then you can define in this way, that the extra effort which is being applied to lift a load is known as effort loss. This is basically due to the friction, and it is termed as effort loss. So effort loss and weight loss, these are the two losses, and these two losses are due to friction. So the effort loss may be defined as the extra effort which you are applying to lift a load, and the weight loss may be defined as the lesser weight which is being lifted up by applying a particular effort. So extra effort which you are applying is known as effort loss, and the lesser weight which is being lifted up is known as weight loss. So these are the two ways of defining the friction in case of a simple lifting machine. The effort loss is denoted by LP, and the weight loss is denoted by LW. These two terms have got individual formulas which you have to learn. Now this LP is equal to P minus W upon VR, and LW is equal to P into VR minus W. Okay, these are the two formulas. One is for effort loss, one is for weight loss. Now come here. Suppose this is also one more than this, and this is also one less than this. So effort loss and weight loss, if you calculate an effort loss and weight loss for any machine, the answer comes to be about same. Okay, this is also one extra and this is also one less. The answer of both the terms LP and LW will comes to be the same, but they are the two different ways to define or to explain the friction in case of a simple lifting machines. This distance is known as effort arm, and this distance is known as weight arm. Okay, so these are the two ways of defining the friction. Now second, the next term, or you can say the next thing which you have to learn is the reversible machine. This is the next topic. This is the important topic, and generally it comes in your exams, the reversible machine. Now to explain what is a reversible machine, again I will give an example of the same machine, that is the lever arrangement. This is the fulcrum, this is the horizontal bar, here the weight is kept, and here the effort is applied. So whenever the effort is applied, the weight moves up like this. So to lift the weight, the effort has to be applied here, weight, effort, like this. Okay, now suppose you have lifted the weight by applying an effort like this. This is the initial position and this is the final position. The effort has traveled through a distance y, and weight has traveled through a distance x. Now suppose applied effort, the weight is lifted up. Now suppose in this position, if you remove the effort, in this position if you suppose remove the effort, then there can be two things. Either the weight can come back or it may not come back. It remains here only. Okay, these are the two conditions. The reversible machine. The reversible machine is that machine in which if you remove the effort, the weight comes back to its original position. That is known as a reversible machine, and the reversible machine is also known as anti-locking machine. Second, if you apply the effort and the weight goes here, and then you remove the effort, then on the removal of effort, if the weight doesn't comes back here, it remains here only, then the machine is known as non-reversible machine. Okay, if the weights come back, it's reversible. If it doesn't comes back, it is known as irreversible machine. Both both on the removal of effort. Effort is removed, it comes back. Effort is removed, it doesn't comes back. Reversible machine and irreversible machine. Now you must be thinking that why the weight doesn't comes back. Okay, to explain this, now suppose I said I have removed the effort. Okay, whenever I remove effort, we are left with two things. One is the friction. Here there is a friction, and this friction does not allows the weight to come back. Okay, this friction restricts the weight from coming back. But this is the output, because the input we have removed and we are only left with friction and the output. The output wants the weight to come back to its original position. That means the weight comes back due to the output, and suppose it does not comes back, then there is a role of friction. The friction does not allows it to come back. To give a live example, suppose this is a pen. This is you can consider it is a bar. If suppose we apply effort here, it will raise. If we remove the effort, it will come back. Now in the second case, suppose I apply an effort and I remove the effort. It is not coming back because the friction here is too much. So whenever I reduce the friction, it will come back. Okay, if the friction is more, it will not come back, and if the output is more, it will come back. Okay, so it will come back due to the output, and it will not come back, then that means friction is more. Now the condition of reversibility. Reversibility means a machine in which the weight comes back. That means one is the friction, one is the output. If output is more, then the weight will come back, and if the friction is more as compared to output, the weight will not come back. Okay, now for reversible machine. For a reversible machine, output should be more as compared to the friction. Come here, see here, the output is more as compared to friction. This is in case of a reversible machine. But you know, friction is equal to input minus output. I have told you this in the definition of the friction, that is, the friction is the difference between input and output. So here instead of friction, you can write input minus output. So the equation becomes like this: output is greater than input minus output. Now take output to the other side of the equation. It will become 2 output is greater than input. Take input here. It will become 2 output upon input is greater than 1. If you take 2 this side, then the equation becomes output upon input is greater than half. But output upon input is termed as efficiency, and half means 50%. That means if the efficiency is greater than 50%, the machine will be reversible. That means it will come back to its original position after the removal of effort. Now if same thing is repeated by taking friction is greater than output, then our equation will become efficiency is less than 50%, and if the efficiency is less than 50%, it will become irreversible machine. That means for an irreversible machine, output is less as compared to friction. So our greater than sign changes. So at last we get our efficiency is less than 50%. So definitely if our efficiency is greater than 50%, it will be a reversible machine, and if our efficiency is less than 50%, it will be a irreversible machine. and the reversible machine is also known as the anti-locking machine, and non-reversible machine is known as locking machine.